Hi, I'm Radha and this is Gautami. We are going to be sharing two sequential lessons for year 3, year 4 students called What's Hidden in Our River. Our lessons are centered around the key focus concept of microorganisms, which also further relates to the concepts of cells, ecosystem, and biodiversity, which will be explored subsequently in order to provide students with richer conceptual understandings. These lesson plans are an extension of the river story, wherein students will be identifying the various hidden microorganisms in the river, investigating the role they play in our environment, and how they affect the water bodies. This lesson sequence on microbiology relates to the biological sciences substrate of the Victorian curriculum, where students would explore and differentiate the features of classified group of microbes as well as the optimal living conditions. In terms of science inquiry skills, students will be proposing through group discussions various ways to conduct investigation and selecting the most appropriate method to find answers to a scientific question related to microbes. Furthermore, the use of various equipment necessary for the experiment will be explored, such as the microscope. Although typically students would engage in this concept in their later years as seen in the VCAA in year 7 and 8, we believe that it is beneficial to introduce younger students to microorganisms as they are vital to the environment, are key role players in food webs, and maintain the balance of the ecosystem by ensuring the continuous flow of energy between living organisms and the environment. Using modern terminology, microorganisms are an underrated group of living things and may be taken for granted, even though we are dependent on them in many ways, such as in the sectors of medicine, food production, agriculture, and environmental protection. This relates to the area of biotechnology, the practical application of science which would act as a stepping stone for students to become active thinkers and problem solvers, skills which are sought after in the 21st century. Thus, by gaining this new knowledge, students would understand the value of microorganisms and our interconnectedness with them, and this would also act as a stimulus that piques their curiosity and appreciation about other hidden aspects of our environment, which will lead to their active involvement in sustainability, and thus play their part in conserving and protecting the environment as informed decision makers and innovative citizens of the future. As mentioned, the microscopic world is usually rarely explored in the younger years due to their complex and extensive nature. Students might have difficulties understanding that they are living organisms dependent on certain conditions for survival, as microbes can only be seen under the microscope. Students' experiences are not lived and concrete but lean more towards the abstract side, and thus they might find it hard to relate to them as they are unable to connect and apply their everyday experiences to this learning experience. Moreover, students may find it challenging to comprehend the concept of microorganisms due to the innumerable types of microbes that are present and the way that they are classified. Additionally, students may hold alternative conceptions about microbes which could possibly impact their learning and understanding. The words microorganisms or bacteria usually imply negative connotation, mostly relating them to diseases and germs. They might thus hold the conception that microbes are dangerous. They may also think that microbes only exist outside of us, but which are actually living inside of us. Students may also misunderstand that microbes are small animals such as beetles and worms. This lesson sequence thus aims to transform their thinking of microbes as only disease-causing, discrete organisms with no part to play in the environment. The first lesson will see students developing a basic understanding of how to operate a simple microscope to observe a slide containing a sample. They will also be tapping on their prior knowledge to identify, describe, and match the different microbes present in the water sample, which are bacteria, fungi, algae, and virus. They would be doing so with the aid of flashcards containing visuals of each microbe. They would additionally continue the exploration of the helpful and sometimes harmful functions of each microbe found in the river. And lastly, they would draw their favorite microbe and state why they chose it, as well as create their own microbe, which would be shared and discussed as a class. The various materials needed range from microscope to Play-Doh. The focus questions reflect Bloom's taxonomy and contains recalling questions through to creating questions. This lesson centers on 3 E's of the 5E instructional model, namely engage, explore, and explain. The role of the teacher is mainly that of a facilitator, initiator of discussions in a student-centered learning environment. In lesson 2, students will delve into an inquiry-based project where students investigate the key question, what is needed for aquatic microbes to thrive? In endeavoring to answer this question, students are tasked to draw on their prior knowledge of living things and connect it to this situation. They will then be asked to propose a model to replicate the river ecosystem, and time will be given for research. After a discussion about the different models, students will be guided to create a Winogradsky column. See description box below for more details. The materials required are listed in the slide and include iPads for students to research online. Similar to the previous lesson, focus questions will follow Bloom's taxonomy. In this lesson, students will engage in 1E of the 5E model, that is 11. The teacher will facilitate class discussions and monitor students' learning. This sequence of lessons proceeds an exploration of the river story, wherein students investigate what lies beneath the river which may not be seen. We have outlined our lesson such that it is preceded by another experiential learning activity after the exploration of the river story. In that lesson, students are introduced to the world of microbes through a combination of thought-provoking questions, as well as their imagination of what it might feel like being a tiny organism in a vast river. Students would then be read the book Tiny to develop a deeper understanding of what exactly microbes are and how they look like, including the use of real microscopic images taken from the flashcards. To conclude, students will be brought to the river near the school to collect water samples for inspection in the next lesson, as well as begin discussions about the types of microbes that might lie hidden in the river. Although these lessons do not directly connect to students' everyday experiences, their encounters with the school river acts as a mediator and thus bridges the gap and aids in the transformation of students' everyday conceptions to scientific concepts. The activities are designed such that students are able to tap into their current understandings of living things to include a different group of organisms and how they interact with the environment. The first lesson focuses on the general aspects of microbes, while the second lesson delves deeper into an investigative mode of acquiring scientific knowledge. It challenges students to draw on and connect what they have learned about living organisms as well as microbes to find out the optimal condition for the microbes to thrive in. These lessons would ideally be extended to allow students to observe and record changes as well as collect and communicate findings. The lesson can also be included as part of a larger unit where students go on to explore microbes and how they contribute to, are affected by, and have the potential to reduce pollution, and extend even further to include biotechnological explorations where the role of microbes in the various sectors are investigated, drawing on cross-curriculum capabilities of intercultural understanding, Aboriginal and Torres Strait Islander histories and cultures, and sustainability. The unit could include incursions of microbiologists or excursions in partnership with organizations such as the Scale Free Network that explores the art and science of the microscopic world. Drawing on the nature of science that is inclusive of a curiosity in finding out the how and the why of science, these lessons are designed using inquiry-based learning as well as social constructivist approaches, both of which point to a self-directed learning and investigative environment where the focus is on hands-on experiences, and students are the driving force of lessons as autonomous decision makers. Both provide students with opportunities to see through and apply the suitable knowledge, acquired knowledge to real-world situations, therein constructing new knowledge. Social constructivism also emphasizes on collaborative learning where multiple perspectives are navigated. Additionally, a merging of both individual and collaborative aspects of student-centered learning takes place in such environments as enabled in our lesson plans. The 5E model of STEM learning places at its core a place-based learning approach which we have situated at the school river. This sparks student exploration of what they already know, which in turn makes visible students' alternative conceptions and what they may have, which may have to be addressed and transformed. The open-ended nature of such projects enables students to be a challenge to tap into multidisciplinary knowledge, also known as STEM, that outline various methods to approach the issue. Lastly, we utilize elements of design thinking that is closely related to engineering and technology, wherein students apply their knowledge about the structures and functions of microbes to create their own. Within this process, students are asking questions, imagining, planning, and creating. Since the investigation will be ongoing even after the end of lesson 2, the forms of assessment we would include for both lessons is diagnostic assessment and formative assessments, which more specifically includes assessments for and as learning. In the engage phase of the 5E model in the lesson, students will be articulating their prior knowledge as well as alternative conceptions, which serves as entry points for teachers to determine students' current level of understanding so as to alter or better tailor the lessons to students' learning needs. Additionally, questioning is an element of formative assessment that elicits students' thinking processes and presents opportunities for teachers to enable or extend their understanding. For example, asking students to predict what might happen aids in the development of scientific skills. Observation is also another formative assessment tool that teachers can employ to monitor students' progress. Lastly, documentation of student learning, namely work samples in the form of drawings, written text, and models, enables students to present their learning in a more personalized and concrete way. Also, it aids in the development of scientific inquiry as they hypothesize about each part of the model, which teachers can consequently build on. Teachers' informal feedback and guiding questions also serve as ways for students to monitor and regulate their learning by attending to any gaps in knowledge formation. The open-ended structure of the lessons enables the accommodation of a diversity of learners with various perspectives to offer, which through collaborative discussions can deepen students' thinking. The student-centered learning environment allows for students' interests, motivations, and curiosity to be built upon progressively throughout the lesson sequence. Furthermore, adjusting the mode of lesson delivery between teacher-guided and student-centered according to the needs of students at that time ensured that understanding of the topic was rich and reinforced. The use of visual-based learning and tools supported students in being able to showcase their learning in authentic and personal ways that accounted for diverse learning styles and needs such as EAL learners. Safety was also considered when handling the various materials for the column. Lastly, the use of diagnostic and formative assessment ensured that each student's learning is accounted for, while simultaneously serving as a guiding tool to inform or alter teaching strategies to ensure optimal learning is taking place. Thank you for your time. Bye-bye.